The Great Red Spot on Jupiter is a long-lasting area of high pressure that creates a persistent storm. It is the greatest storm in our solar system, and it appears as a giant red patch on Jupiter's surface. It is located in Jupiter's southern hemisphere. According to NASA, it has been around for at least 150 years, and possibly even longer. According to the American Physical Society, the location was discovered in 1664 by English scientist Robert Hooke or in 1665 by Italian astronomer Giovanni Cassini. It's possible that one or both men saw the shadow of one of Jupiter's moons, or a different location. A depiction of a red spot on Jupiter like the contemporary spot first appeared in 1831, and it has been observed continuously since 1878. When it was rediscovered by American astronomer C.W. Pritchett. The Great Red Spot is an anticyclonic storm, a type of storm that occurs in high-pressure zones on Earth and other planets. According to the planets, it rotates counterclockwise once every 6 days and creates winds of high to 580 mph in Oldenthine and 1203 kfar. According to Smithsonian, how did it come to be? Anticyclonic storms form on Earth when high atmospheric pressure forces cold air from higher altitudes down. They are common in high-pressure systems and are frequently connected with cold weather. They can also spawn supercell thunderstorms, a rare type of thunderstorm capable of producing anticyclone tornadoes, according to the Planetary Society. While scientists understand how these storms form on Earth, no one knows for certain how or when the Great Red Spot arose. What is the size of the Great Red Spot? The Great Red Spot is 10,159 miles 16,350 kilometers across, or roughly 1.3 times the breadth of the Earth 7,918 miles or 12,740 kilometers. It used to be much larger though. It was thought to be roughly 30,000 miles 48,280 kilometers wide when it was first discovered in detail. In the late 19th century, more than 3 times the width of Earth. The reason for the Great Red Spot shrinkage is uncertain. It's possible that the weather patterns that keep it going have just peaked after several hundred years. According to NASA, there is additional evidence that the spot has grown rather than diminished throughout its history, with some growth recorded as recently as the 1920s. The spot appears to be changing shape, color, and other characteristics in addition to shrinking. According to a 2018 study conducted by NASA and the University of California, Berkeley, the storm appears to be becoming higher as it retreats. A few years later, some of the same researchers discovered that the wind speed at the location was gradually increasing. Given that the reasons for its shrinking size are unknown, it is also unknown how long the spot will endure. According to some research, it could vanish in 1 or 2 decades, but it could potentially survive for centuries. Why do researchers believe the Great Red Spot is diminishing and changing in other ways, such as growing taller? On Jupiter, rotating storms, hailstorms, and anticyclones often arise from a much larger weather system that condenses into a unique storm. Jupiter's alternating pattern of high-speed and practically continuous eastward and westward winds acts to channel storms and confine them to a narrow area of latitude. What produces the red hue of the Great Red Spot, and why might it be changing? We don't know what causes the GRS's hue to shift from very pale to vividly red-orange. According to modeling photos obtained at different wavelengths of light, the colorful particles appear to be in the upper hazes at or above the storm's summit. At these altitudes, a variety of hydrocarbons and other complex chemicals interact with sunlight, contributing to its peculiar coloring. Laboratory investigations reveal that many of these compounds turn orange when exposed to UV radiation. The precise color of the GRSAs at any particular time is frequently determined by whether or not fresh clouds which are white have been brought into the storm. Continued monitoring will reveal whether those interactions change as the GRS shrinks, what historical observations regarding the Great Red Spot are available, and how might they help us better understand it. The GRS has been seen continuously since the mid-1800s, which is a remarkable historical record. Early records in the 1660s indicate a point, but it was considerably smaller and possibly at a different latitude. According to the continuous record, the GRS was substantially larger in the 1870s, reaching over 45,000 kilometers in longitude. This lengthy time span of data is useful for understanding how wind interactions may have altered over time, which we are only now beginning to untangle using computer simulations of storm size, shape, and speed. So that's all for today, folks. Subscribe if you want to watch more videos like this.